Okay, at the end of the flight, the container of a total mass of 480 kilograms falls into the tank of expanded styrofoam to slow it. This is very much, by the way, like the drop tower at Glenn Research Center, only they don't fling it in the air. They've actually discovered that when you fling it in the air, the whatever flings it disturbs the experiment so much that doesn't really work. But anyway, it's a neat concept. Anyway, so what you're going to do here is you're going to figure out the deceleration. Find the the thing's going to fall, right? It's going to be like, here's our expanded foam, right? It's going to accelerate down, right? And then it's going to decelerate for some distance into the foam, right? 8 meters, I guess, right? In this part here, it's actually going to accelerate upwards, right? So the first thing to do is to find your the deceleration, right? Which, by the way, will be a positive acceleration. It's going to be upward, okay? Deceleration. Tough day. All right. And so what we're going to do is we're going to SUV AT. Our initial velocity is negative 48. Our final is 0. Our displacement is that we go down 8. Did you notice it? The displacement would be down. I think ultimately you can SUV out that and find the acceleration. If you don't arrive at a positive acceleration, slap a minus sign on it, right? Because you stopped going down. If you stop going down, that's a positive acceleration. It is positive something, right? Okay. Now you've got the acceleration, so now you're going to take this container as it's burrowing into the styrofoam, right? Okay. There's going to be the force of gravity down, right? There's going to be some giant force upwards, right? This is the force you're trying to find, right? So you're going to go force minus the force of gravity is equal to m times the acceleration, right? And this is a big positive number, more than 100, less than 200. I'm just going to tell you, okay? Force of gravity is going to be roughly, 4,700 something newtons, right? It's this times 9.81 if you forgot how to do that, and then this is what you're trying to find. Yay! All right, and then C, I don't think I actually got C entirely right. It's like two things that we need to talk about. Ultimately, what they're trying to say is that they're in weightless conditions, right? And so what you need to explain is why is it that, if say you're looking at this container as it's accelerating down at 9.81 meters per second squared, why is it that if there was something in here, there would be no force of contact between this object and this object? Okay, why wouldn't this object be pressing down against this object? Okay, that's what they want, and I'm not sure I actually covered that when I answered it. But anyway, there you go. Good luck.